For example number 7, 1989 AB3, we're given a particle moves along the path described by the horizontal component x of t and the vertical component y of t from 0 to 6 seconds. They asked for a few things. First is the position of the particle when t is equal to 2.5. The position is something we can find if we have the position function simply by plugging in using direct substitution and evaluating. We must evaluate all trig functions. So as we plug in 2.5, we want to also make sure that we complete the evaluation of the unit circle. So cosine of 5 pi over 2 and comma 5 sine of 5 pi over 2. So when we think about 5 pi over 2, that is 1 more pi over 2 over 4 pi over 2, which is a full revolution. So cosine at that value is 0. And then sine is 1. So 1 times 5 is 5. So our coordinate point is 0, 5. Find the velocity vector for part B for the particle at any time t. So the velocity vector would be equal to the derivative of cosine is negative sine, and we want to multiply by chain rule the pi. So negative 3 pi sine of pi t is the horizontal component of my velocity vector. Then we take the derivative of 5 sine of pi t. The derivative of sine is cosine, and then times by pi as well. So 5 pi of cosine of pi t. Now they ask a secondary question, which is find the speed. If we think about speed as the magnitude of velocity, then that means we're thinking distance formula, we're thinking Pythagorean theorem, and we're squaring the horizontal component of our velocity vector, which we just found, and then adding that to the horizontal component that we just found. So I'm just simply plugging those in, and if we look, it says at a moment in time, at 5 halves again. So if we plug 5 halves into the first part, once again, this is going to yield 1 for the sine part. So 1 times negative 3 pi is negative 3 pi. So we have the square root of negative 3 pi quantity squared. And then the cosine part of it is going to be equal to 0. So therefore, we don't have to pay attention or any mind to that. And then taking the square of that and then the square root, they'll undo each other. And also, squaring it is causing it to be positive. So in taking the square root, we have positive 3 pi is the speed of the particle at 2.5. Now contrast that, and these two get mixed up a lot, these two concepts of speed and distance traveled. So write and evaluate an integral expression that gives the distance the particle travels along the curve from t equals 1.25 to t equals 1.75. So we want to find the length of the curve that's traveled. So the arc length formula is what you're thinking of. And so this one was a calculator question, so I'll put a little star by this. I want you guys all to try this on the calculator, making sure that you are able to find this, because these are oftentimes calculator questions on the vector, parametric, polar for response. So if we plug in our expression, essentially the expression that we had above into an integral going from 1.25 to 1.75. Also, we're integrating, so make sure that you guys have your velocity and your velocity horizontal component and your vertical component squared as functions of time t. Don't plug a constant in, otherwise you're integrating a constant. So in this case, I plugged, and you can see the expression for speed is the exact same thing as the function that I'm integrating here. And then making sure that when you plug it into your calculator, if you've already used the velocity components as y1 and y2, you can also leave this in y1, leave this in y2, call those variables on the home screen as you're integrating. And then that way you're integrating y1 squared and y2 squared, as opposed to entering in a giant integral expression like this. Either way, please double check your answers, but you should get 5.392.